This slide I mentioned yesterday, but for those who weren't in my talk yesterday about dates and times, I now start and end every talk with just a slide saying to be kind. This isn't that you're not kind already. It just helps us to all be reminded that kindness is an important part of life. Okay, so today we'll be talking about versioning. And versioning is something that has been on my mind for the last few years. The previous few years were largely taken with dates and times and things. But versioning has been very important in my work in terms of APIs and libraries and languages and now events and all kinds of things. We use versions all the time. So in this talk, we'll go into a bit of detail about why we have versions at all, what they can look like, the different characteristics of different kinds of version. And then we'll dive into a bit of detail about semantic versioning and how libraries for .NET are versioned and how that kind of causes a problem. But first, I want to talk to you briefly about a little game called Hanabi. This is a game that I was introduced to at the CodeMash Developer Conference, and I have since introduced it to my kids, and it's a fascinating game. I thoroughly recommend that you get hold of a set and start playing it. But the important thing is, Hanabi is a game of trust and communication. That's how a friend of mine, Jean, always introduces it. And there's a good reason why I'm bringing this up in a versioning talk. Because in Hanabi, it's a collaborative game. Everyone's trying to do the best they can with everyone else. And you're doing so with a very, very small amount of information. Information is sort of the currency of the game, and you're trying to communicate as much as you possibly can with a really small piece of information. And you have to trust that everyone else is also trying to communicate as best they can with you and accept what they say. If you haven't spotted already yet, that's really similar to versioning, where we use a version number to communicate as much as we possibly can in just a tiny 1.3.2. That's just 3 numbers. What on earth can we communicate within that? Well, we'll go into details of semantic versioning a little bit later. But this idea that it's collaborative, it's a model of trust, and it's a model of how much information can we sensibly communicate with a small amount of actual text is really important to my feelings and my thoughts around versioning in general. I should say at this point we will have, I think, 3 question breaks, so do add questions to the chat, and every time we come to a question break, Max will go over the questions so far. Just to highlight the areas that we'll be talking about are versioning in general. We'll talk about Semver, we'll talk about .NET libraries themselves, and then in a final section I'll talk a little bit about RPC, so service-based versioning, and maybe cloud events, and a few things that are a little bit outside our normal realm. And of course, we'll have time in the webinar Zoom conference afterwards to take more questions. But if you have any questions as you're going along, then please put them in the chat and we'll get to them when we can. So, what is a version? Why do we have versions at all? Is this something... It feels like this is an area where the rest of the world, outside tech, the idea of a version doesn't crop up nearly as much. So we need to work out why we've introduced this idea into the tech world at all. What are we trying to get out of it? And it's communication. It's like a contract between 2 parties. It's usually an identifier of some kind, usually textual. I don't know of any versioning schemes that don't use text. It would be a bit awkward, let's say. But it's always about change. It's about how something evolves, where that something is like the target of the version. So maybe it's a library, so my Noda Time library, or in fact, while this talk is going on, I'm publishing a new version of our Google Cloud Spanner libraries. So hopefully by the end of this talk, google.cloud.spanner.v1 version 3.1.0 beta 01 will have been published, and that includes two versions. One is the version of the API, the v1 at the end, and then there's also the version of the library for that API, which will be 3.1.0 beta 1. So that's targeting a library. There's also languages. We've seen C# 8 came out last year. Before that, we had C# 7.0, 7.1, 7.2, and 7.3. What does it mean to have a major version in a language versus a minor version change in a language? There are whole platforms, .NET as a platform, for example, and even books. So as Max mentioned, I'm the author of C# in Depth. This is actually the 3rd edition. I've got copies of the 4th edition sort of elsewhere in my shed, my home office. So I'm on to version 4, and at some point fairly soon, I should probably start writing version 5 of C# in Depth. And that's an addition in some senses. My wife, Holly, is also a children's author, and in fact, she would have been in Russia a couple of times if it weren't for the coronavirus during March and April. So she's called Holly Webb, and she writes children's books. And we've talked about the fact that my book is just, the 4th edition. And if Holly had a 4th edition of a book, just be, well, reprinting the same thing, maybe there would have been a couple of typos to correct. But the idea that a 4th edition would be a complete rewrite over the 3rd edition means that that just confuses her, or rather it's not the kind of editions that she would expect. So even within one domain of publishing physical books, versioning can mean different things. And in change, then it doesn't need to be versioned, because it's always going to be something, be the same thing. Versioning is tightly coupled to how something changes. And the sort of opposite of that is, if you think something will change, it's a good idea to work out what versioning means for that. I recently was discussing this with cloud events and how you say what. I was arguing quite passionately that we need to include a version number within that type so that we can evolve it, even if for most of the cloud events we never have to. Having somewhere that you can go if you need to evolve it in a breaking way in particular is really useful. So when you're thinking about versioning, you're thinking about change, you're thinking about breaking changes, backward compatible changes, and not changing things at all. Okay, so I've mentioned that we've got usually textual versions with a target, and they may or may not be human memorable. I have just the Cloud Spanner library that I'm publishing, 3.1.0 beta 01. I can remember that. It's fairly easy. Someone less buried in my realm might sort of have to look it up, but they could probably repeat it to someone fairly quickly. There is no way I have remembered the git hash that corresponds with that version in source control. It's just not memorable. That's an aspect of how version formats can differ. But there are other ways as well. Things like identity. In most things, certainly Git commits and library versions on NuGet at least, but maybe not in some other platforms. If you download 1.2.3 and someone else downloads 1.2.3, or you do 2 years later, you expect to get the same thing, the exact same thing, bit for bit. No bug fixes applied, nothing. In some other languages, maybe they say, oh, do you know what? If it's really a very non-breaking change, no behavioral change, if you've just modified the documentation, maybe that's okay to republish an existing version. So when you're considering your own versioning scheme or how you fit into a versioning scheme, think about whether the version has identity. does the same version always mean exactly the same thing? Another aspect to consider is ordering. So semver numbers for libraries are partially ordered chronologically. So for example, you would always publish 1.2.0 after 1.1.0. And can you imagine if someone said, okay, today I'll publish 1.2.0, tomorrow I'll publish 1.1.0. It makes no sense. But it's only a partial ordering. You can publish 1.1.1 after 1.2.0. If you find there's a bug in 1.1.0 and you want to fix it, then it makes complete sense to publish one at a time. I published 2.0.0 and then I published a 1.4.0 that was meant to be a sort of compatibility step. So there's only some ordering, and you need to be aware of that. For Git commits, I've mentioned they're not memorable. They're also not obviously ordered. Within the context of a repository, you can say, well, what happened between this commit and that commit? But unless you have the repository there, you have no idea. If you just look at two commits, you cannot tell which came first. There are also the idea of aliases or marketing names. So, for example, within Debian, stretch is the alias for Debian 9, and something like Visual Studio 2017 is version 15, and Visual Studio 2019 is version 16. So Java goes particularly oddly around this. Java 8, is that Java 1.8? It's all kind of hard to get your head around. But it's worth being very clear in your mind what version applies to what. Okay, let's give a complete example here. I hope all of this is correct. I only updated this slide this morning. So if you download .NET today, you might download the desktop framework 4.8, or if you're keeping up with the times, you're onto .NET Core and you might download SDK 3.1.301, which includes the .NET Core Runtime 3.1.5, which implements .NET Standard 2.1, not 3.1, but 2.1. And that SDK allows you to write code in C# 8. And then you use that often within Visual Studio 2019, version 16.6.2. So just thinking about, what am I developing in today? You've got all these version numbers. And pro tip, if you're reporting a bug, particularly saying, I can't compile this sample or whatever, it really helps to give as many of those version numbers concisely, but express them so that people know what context you're working in. Speaking of context, let's think about what can be version. We've just talked about the SDK and the framework, but what else? Well, there might be an application. We've mentioned Visual Studio. There might be Windows, and there we've got Windows 10, but a particular version of Windows 10 and whether it's on the insider track or not. We've got the version of the language, the version of the platform, so .NET Core, and what you're running against versus what you're developing against. You might be developing against a version of Noda Time, for example, and then taking the output of that and sending it over a particular protocol, so HTTP 1.1 or 2.0, for example, to talk to a particular version of a service. Oh, it all gets quite complex. There are lots of versions going on. When you're thinking about what versions you want to use and any versioning systems you want to apply, you need to be aware of how the context in which you're operating and your customers are operating affects how you handle versions. So if you're building, for example, an application, you need to know how your dependencies behave. If you are an application that depends on Noda Time 2, Noda Time version 2.4.8, for example, and you want to know, can I update to Noda Time 3.0? You need to understand what that change means. If you are, on the other hand, building a library or a networked API, you're probably thinking more about what your callers expect. So how are you going to publish your next version and explain what's changed? Ideally, obviously, in a release history, but also just in terms of the version number and what that implies. There can be not isolated concerns as well. I build libraries, and they depend on other libraries. I try to reduce those dependencies where I can, so Noda Time hardly depends on anything. The spanner library I was referring to before, if you look at its transitive set of dependencies, so everything it depends on, everything those dependencies depend on, etc., until you reach the end, there's a lot. And that's to be expected because it's doing quite a few things. It depends on protocol buffers and some general API support libraries we have, and authentication and gRPC and common spanner libraries, admin spanner libraries, all kinds of things. How does any of those dependencies change how I then version my next version of the library? I'm not giving you answers to all of this. I'm saying these are things you need to be thinking about. And you shouldn't expect the answer that you come up with for today's context to necessarily be correct for tomorrow's context. And that can even be more subtle than, well, I'm building a library today and an application tomorrow. Suppose you're building a library and it's internal to your company and you can find all the code that uses it. Wow, that puts you in a really strong position to make breaking changes because you can fix all the code that uses it first and say, okay, has that all been rolled out? Great, I can get rid of this method that I didn't like or that I put the wrong name on or whatever it is. If, on the other hand, you're working on open source, which most of my time is spent doing, wow, that's really hard. I have no idea how my users are using the code. I could have some instrumentation, and if they're using it to call into, I keep using Spanner just as a simple example, but the Spanner database API, then my colleagues can tell me, oh, well, we have received this many requests to do with .NET. Obviously, there are privacy concerns, and we don't keep track of exactly who's calling what and let everyone know that. But we will get some aggregated logs for, okay, it looks like no one is using this particular RPC. Maybe we can consider deprecating it in some smooth way. So it gets really tricky. You've got at the one side internal APIs that you absolutely know who's using what, open source APIs with no networking component and no telemetry, no idea how they're being used, and network APIs where we have some idea, but if there's a library that exposes that network API, even if no one's making the call, you could still break their code by deleting that method. So it's really tricky. Okay, we're going to have our first question break now. So if you have any questions about versions in general, so what we've covered so far, and just how we think about versioning, then now's the time to ask. I would say if it's about Semver in particular and .NET libraries in particular, probably wait until another break. So Max, do we have any questions?
No, not so far. So I assume that people are still listening to the talk, so we can continue.
Okay, let's keep going then. Okay, so let's talk Semver. So this is an example of a semantic version. It has a major version number, a minor version, and a patch. So major, minor, patch. Major is 1, minor is 2, patch is 3 here. What does that mean? Typically, well, the definition of Semver is that if you want to make a breaking change, you have to bump, you have to increase the major version. So we go to 2.0.0 if we wanted to make a breaking change. If we wanted to make a non-breaking change going forward, so that anyone using 1.2.3 could use our next version, whatever it is, then we could, but the reverse isn't true. If someone using our new version might not be able to go back to 1.2.3 because, for example, we're adding a new method or a new class, whatever it is, then we'd need to bump the minor version, so we go to 1.3.0. If we're making something that's back and forward compatible, which is almost always just a bug fix or maybe documentation fix, then we would make a patch version. So that would be 1.2.4. And the important thing is there that it's forward and backward compatible, that if someone takes 1.2.4, they should be able to downgrade again to 1.2.3 and their code will not break, other than in terms of the behavior of the bug that you fixed in 1.2.4. So it gets a bit subtle, but subtlety is all about Semba. So I've talked about breaking. What kind of breaking are we talking about? Now, I'm going to assume we are talking about a library, and I will talk about it in terms of C#, because I think hopefully everyone listening to this is familiar with C#. But even really hard to say what's compatible. So almost any change to a public API could break someone. And that's really hard to hear because it goes against our natural ideas of things. So, for example, if you add an overload to a method, I could probably write code that makes that a breaking change. Okay, if I try really hard, almost anything you do is going to be breaking. So adding an overload, there are some things that are more obvious. So if you change a field into a property, most of the code might be okay. But if someone is trying to pass that field by ref, then suddenly, no, they can't do it anymore. It also, changing a field into a property can break reflection. If you're using bindings that expect things to be in fields, should you make things reflection compatible? Should it only apply to public things? I would certainly argue that while renaming a private field is visible via reflection, I would never decide that that was a breaking change, because otherwise just everything has to be new major version, boom. And it's really difficult. But other things that we wouldn't expect to be breaking, how can adding a class be incompatible? You add a new class called, say, type, then anyone who has a using directive for your namespace and a using directive for system, and then types type t equals, type of string, suddenly it's, this is ambiguous between System.type and my nasty library.type. And that catches me out all the time, because within the Google libraries, we do have a Google.type namespace that's for protocol buffers, and I can't really change that because that's generated from other protobufs. But it makes it quite tricky. There are other changes that are harder to reason about, say performance changes. Say I look at Noda Time and think, I can really optimize this common case. And in fact, I did this before the 3.0 release, so it would have been fine anyway, because it's a major change. But I optimized for the common case of what you're formatting is an ISO date, basically. In that case, there are all kinds of checks we don't need to do, so we can make that really common case much faster. Really significantly faster. But that is adding a little check. So that makes the not common case very, very slightly slower. Does that count as a breaking change? Well, it could break someone. So almost anything can break people, but we need to have a useful definition of what counts as breaking. We also need to think about binary versus source breaking changes. If you need to recompile, but then it's fine, does that count as compatible or not? I would usually try to maintain binary compatibility so that if you use Noda Time version 3.1.0 and something had previously compiled against 3.0.0, then it should still work. And we'll come into why that's important a little bit later when it comes to diamond dependencies. So you need to define what compatibility means for you. The idea of source versus binary compatibility, of course, doesn't map to all languages, because not everything has a compilation phase. And there can be binary compatibility in some senses, but not others. Suppose your new version of a library had an extra dependency. So just copying the raw new DLL might not work. But if you're using NuGet, etc., and that's making sure that, okay, you built some dependency you were running built against 3.0.0 of Noda Time, but now you're running against 3.1.0, that it will still be okay, but it needs an extra DLL which will be supplied for you. Is that binary compatible? Oh, it's so tricky. In case you hadn't noticed, the big point here is that it's not nearly as straightforward. It's not as binary as Semver suggests. Most code has multiple dependencies, and all of those dependencies are versioned. So the compiler, the runtime, the libraries, the operating system, and you've got to imagine moving in this multi-dimensional space. We've got one point in 15 different dimensions. Is it safe to move to another point in those 15 dimensions? There can even be changes, so something that isn't a breaking change in one version of a language could be a breaking change from the perspective of someone else, and that could even be retrospective. So as an example, in C#, I think it was 6, the rules for extension methods changed a little bit in a way that meant something that was previously compatible, changing a regular static method to be an extension method. There are situations where in C# 6, that's a breaking change. But what if you previously published a 1.0 and then a 1.1 because, hey, it wasn't previously a breaking change, and someone with a C# 6 compiler uses your 1.0 and then upgrades to 1.1, and then it's broken? Is that your fault? Well, you couldn't possibly have predicted what the language changes would be and that they would make things a breaking change. All of this is intended to some way, in some senses, to make you go, oh, versioning is harder than I'd ever thought. And that's a good thing to start with, but I promise we'll come to some of the answers. The main thing I want to get across is that you should be thinking about these things. Just as with my date and time talk yesterday, it was, if you think about it, there are reasonable answers. It won't become easy, but in many cases it will become reasonable. So document what you count as breaking. I would love to see more tools that can tell us what's breaking and have it so that you can configure. This project uses this idea of brokenness or breaking change, and I can validate that all my releases comply with that. Okay, we're going to take another question break, and I see in the chat that there have been some questions on some Semver. Let's see. Well, Max can read them to me because some are in Russian that I wouldn't understand anyway.
Yeah, so but most of them are in English. So the first is, it's not so clear. It's not clear enough defined in Semver what version should be raised if backward compatible change, which is related neither with bug fixing nor introducing substantial new functionality. Let's say refactoring was done. Should minor or patch was raised in this case?
So if it's a purely internal refactoring, then that's patch, because you could move from, say we were at 1.2.3 and we did some refactoring. I would question, do you actually need to release this at all? What is the user visible benefit of you releasing this? But maybe it reduces the download size or something. But assuming people can go arbitrarily between 1.2.4 and 1.2.3, then that's fine to be a patch. If it's actually, well, I introduced this new class to better encapsulate something, then that's a 1.3.0. You've added something, even if it's not the question uses the word substantial new functionality. If it's any new part of an API surface, then someone depending on that would be broken by downgrading back to your previous version. So that has to be minor. Some refactoring, renaming a class, that's a major breaking change. Even if you've got no new functionalities at all, you cannot expect existing code to just work. So that would be a breaking change, and you you'd have to go to 200. So I hope that if you think about the impact on clients rather than what you did to get there, then hopefully it's clearer.
Mm-hmm. So the next one, I think that you might partially cover this question, but anyway, so don't you think that some version doesn't fit well with .NET or Java world, as it justifies breaking changes, so transitive dependencies just can be resolved properly?
I would rephrase that as .NET and Java don't work well with semantic versioning, despite claiming to. NuGet is designed around semantic versioning, but .NET doesn't handle it properly. And I will talk much more about that in the next section. So I'm going to just punt on that question for a bit. But please, if you feel that I haven't covered the question later on, then do ask with more context. That's fine.
Okay, so the next one is, how are you handling versioning in APIs through roads,
I will come to that later on as well.
In a way. Perfect. So let's continue then.
Okay. So let's talk about dependencies. And I've already said about how if we're following Semver, so I'm going to assume for now that we're in .NET and we are trying to follow Semver. So suppose you're writing a library and you depend on Noda Time. Your current release is 1.2.3 and you depend on an ancient version of Noda Time 1.10. Okay, if you want to upgrade the version of Noda Time you're using, what do you do? And I can tell you my policy for this. And as I said before, it's not a binary thing. You can decide your own policy, but let's give you my opinion. Mine is you follow the same bump level of your dependency. So if you want to increase to Noda Time 1.1.1, then you would need, so that's a patch version of Noda Time, you would do a patch version of your own library as well. So you'd update to 1.2.4. If you update to Noda Time 1.2.0, then which is a minor version bump, then you would need a minor version bump in yours, so 1.3.0. Likewise, if it's a major change, then you'd need to do a 2.0.0. It doesn't matter whether that major change is skipping multiple things. So if you updated from Noda Time 1.1.0 to Noda Time 3.0.0, so you're going 2 versions of Noda Time, you still only need to bump, and you should only bump by one major version. So you go from 1.2.3 to 2.0.0. You don't say, oh, I need to skip to 3.0.0. And likewise, if your dependencies in the same release, you just take whatever step is bigger. So maybe you're doing a patch version of JSON.NET and a minor version of Noda Time. You just need to do a minor version in general. But this business of dependencies introduces the idea of diamond dependencies, and that's where, frankly, things get really messy. So let's look at this example. We have an application which depends on libx and liby, and they both depend on libz. And this is where, coming back to the question that was asked in chat, .NET just doesn't really work properly. Because if libx depends on libz 1.2 and liby depends on libz 3.2, we know that 3.2 and 1.2 aren't intended to be compatible. They may be mostly compatible. It may be that all that was removed between 1.2 and 2.0 was something that no one calls, and then all that was removed between 2.0 and 3.0 was something else that no one calls, and that libx is fine to run against libz 3.2. That would be nice, but there is no guarantee of it. You have to imagine that a major version could mean everything changes. They decide to use an entirely different namespace, for example. So that's one way that diamond dependencies can really hurt you. Another is without even 2 different libraries being, or 2 different direct dependencies that both depend on something, where this is no longer a diamond. If I go back to my previous slide, if you imagine just one box for libz, that had 1.2/3.2, then we would have a nice diamond in our dependencies. And that's why it's called a diamond dependency, because it's one thing depending on two things depending on the same thing. While this isn't really a diamond where the application depends on libx and libz, but libx also depends on libz, this isn't your traditional diamond, but it has exactly the same problems. So the big question is, what do we do about this? I have some ideas, and I've been talking over these with Rich Lander a bit. I hope to find some more time to talk over them in more detail, and I hope we will get better. But there are possibilities. One is, it depends on whether the libz dependency in libx is ever exposed. For example, maybe libx has a method that's got a parameter where that parameter type is from libz. Or maybe it returns something from libz. It gets slightly trickier if it returns something and it's declared to return object, but it happens to return something from libz. That gets really tricky, but we'll leave that to one side for the moment. If it does that, if libx exposes things from libz, I would call that dependency a public dependency. It's not just an implementation detail, it's something inherent. You can't get rid of it without changing the API surface. So that's a public dependency. Now imagine that libz is something that is only used internally. It's an implementation detail. It would be entirely possible for libx to rewrite all the functionality that's within libz that it uses and remove the libz dependency. I would term that a private dependency. Now, currently, .NET doesn't have any notion of these private versus public dependencies, and maybe it could. So this won't be perfect because not all dependencies can be private, but where they can be, if we made them private, then maybe we could handle it by publishing a NuGet package where the major version is baked into the DLL name. And at that point, different private dependencies for different major versions will use different DLLs. For the same major version, they'd use the same DLL, and you'd sort of get the best of both worlds-ish. Or maybe every private dependency ends up using a new assembly load context, and they truly get different versions. And even to the extent of, if we were back on libx and liby, if they both depended on libz 1.2 as a private dependency, maybe they could both have their own copy of libz 1.2 in memory with separate static fields and everything. You know, entire isolation. Now, I hope you're already thinking, oh, but there are performance problems. Having lots of copies of a library in memory isn't a good thing. We get different jitting. But there's advantages as well. The more isolated things are, the less they can interfere with each other. So suppose libz had some global mutable state, had a static field of current configuration. Okay, I'm not saying this is good library design. It's really not. But maybe that's how it's been designed. And libx says libz.current configuration equals stuff that I need for libx. And liby says libz.current configuration equals new stuff I need for liby. If they're entirely separated by assembly load contexts, then we're fine. They are nicely isolated. It's as if you were using different microservices for libz. But it comes with a performance cost. It also comes with a cost for you can't move references between things. Even if you cast, you couldn't cast a libz 1.2 configuration to a libz 1.2 configuration from somewhere else. You don't have this sort of reference transparency. So that's one aspect that we could introduce, is private assemblies and then private references. private dependencies, third time lucky, and the compiler could say, okay, well, you've declared that you want this to be a private dependency, but you seem to be exposing it in a parameter type, so no, compile time error. There are definitely ways that we can do things. The other thing that I think we can do is to improve tooling. So by the time you've done maybe a .NET publish, you have all your dependencies on disk and your application. And at that point, it shouldn't be too hard to at least do something to give you some confidence. If you're worried that between libz 1.2 and libz 1.3, someone has renamed a method or deleted, you should be able to take, this is my published application with all the dependencies, and walk through every dependency and say, okay, this is the version of libx that we're using, and here's everything it needs from libz. Do those all exist in the version of libz that we will actually be using? Again, that then doesn't work if you're loading time. There's all kinds of restrictions, but I hope it would give us much more confidence than we have now. So I hope that makes a certain amount of sense. I'm going to take another question break. That was a fairly short explanation of what's breaking and a couple of suggestions for how we can improve things a little. My guess is that this will generate lots of questions, and I should just give my normal apocalyptic warning that if you think all of this sounds a little unlikely to happen, imagine if JSON.NET, so Newtonsoft.json, said, do you know what? We're fed up with using the namespace Newtonsoft.json. In JSON.NET version, or in the package called Newtonsoft.json, version 14.0, or whatever it's got to, +1, we will change the namespace to be JSON.NET everywhere. And hey, we can do that because it's a major version. It's fine. The whole of the .NET ecosystem then explodes when anyone tries to use a mixture of 14 and 13 or 14 and 12, whatever's current. So we've been getting away with this for a very long time, but I don't know how much longer we can get away with it. It's already definitely causing problems, and I think we could really do with taking some time, the community working with Microsoft to say, okay, how can we at least improve things? Not aiming for perfection, we're never going to get there, because perfect means different things in different contexts. But we can do better. Okay, let's take some questions.
Okay, and so the next question is, there are also cases when cultural beliefs affect skipping some version numbers. So I assume that Amal's share is referring to .NET 5. No, actually, I think that's something about number 13 or something. So have you ever faced such case?
I can't say that I have. I would be reluctant to do so, to be honest. I would try to keep, by all means, in your marketing version, do something, skip 13 should you wish to. If I were just writing library versions, I would view them, these are just numbers. And if you skip 13 because you know it's going to be unlucky in some cultures, do you find which numbers are deemed unlucky in every possible culture and skip all of them, at which point you go sort of, right, 1, 2, 3003, 10,005, and it's just, no, that becomes ridiculous. So I would resist it unless I had a really, really good reason. If I had a major customer who said, we're not going to take a version 13 because it wouldn't go down well with our engineers, okay, that's a practical reason. It may not be a practical reason for them to want to skip 13, but it's a practical reason for me to want to skip 13 because I don't want to lose my customers. So I wouldn't be dogmatic about it, but I would at least try not to go down that route.
Okay, makes sense. So what other versioning schemes exist except some version like? It's quite widespread, but what else can be used? Do we have any competitive standards in the area, and Alec is answering that calendar versioning might be a competitive standard. So what do you think?
Right. So I haven't used Calver, and it sort of, so just looking at the webpage, Calver is a versioning convention based on your project's release calendar instead of arbitrary numbers. Well, yeah, I dislike that, because I would say that a calendar is an arbitrary number, whereas Semver is not an arbitrary number. It has well-defined meaning, whereas there should be no difference. If I have two parallel universes, and in one of them I release something in 2020, and in a different parallel universe I release the exact same code but on the last day of 2019, when I release it has no impact on my users. Additionally, what do you do about patches? In Semver, it's really easy. If I find there's a bug in 1.10 after I've released 1.20, it's easy. I do 1.11 because chronology, the ordering in time, does not really impact the compatibility. So maybe Calver has something for that. Having only briefly looked at the webpage, I'm not even sure whether it's tongue-in-cheek or not. I know some things are, I think JetBrains tends to release things on a date basis, and there's certainly reason for using, say, timestamps in a build number as a fourth build component as a way of effectively getting a unique ID that can be easy to understand later on. It's nice to know when something was built. But that's not the primary piece of information. It's like deciding to name a book based on the color of the cover. It doesn't tell you anything useful. When I am using an API, using a library, and considering should I change version, I don't care at all when either of them was built. I want to go to a later thing, so I potentially want to go to a later thing if it's compatible, and that's where the whole being able to retrofit a patch is important. I don't want to go backwards without knowing that, and that's fine. But I really don't care whether you published it in August or September. That doesn't have any meaning to me, whereas compatibility does. And this is where, going back to the very start of the talk, when I was saying we don't have much information here. We have a small amount, 3 numbers maybe. Now, you can choose to make those 3 numbers really predictable but useless things, the year, month, and day, or you can choose to convey useful information in terms of, do I think this will break you? And even though we don't have firm, rigid guidelines for what that means, it's still doing that on a best effort basis is better than not doing it at all. In Hanabi, you can tell people, these tiles are red or these tiles are 4s. You can't, and you wouldn't want to say it's 4 o'clock in the afternoon, because that doesn't give you anything useful. So I would go against Calver for libraries. Now, there's an argument, and I've talked about this with colleagues around versioning networked APIs around, well, we're doing things on particular dates and there's maybe no concept of a patch there. And you can say, well, please give me the answer that you would have given me on a particular date. And it's maybe not necessarily that there are specific versions that you need to adhere to, but there may be points in time where we've cut a particular release and we can always make it look like that. So include the same fields that you would have included on June the 10th, for example. There's scope for that. Now, having just said, I don't like Calver, I didn't look at it in detail, and I'm very nervous about dismissing things without looking at them in detail. So I don't like the idea on first glance, but I will have a look later on. I do think that Semver is trying to do the right thing. It's trying to convey the information that I view as important in my dependencies, which is, are you going to break me if I move forward and if I move backward? There may be other things around Semver that aren't ideal. We haven't even talked about pre-release stuff, but Semver seems to be pretty good in terms of its ideals. as I say, there are problems in terms of .NET's implementation of Semver, and maybe that's a problem with Semver itself, is that it's unimplementable in the majority of languages.
Oh, okay, we have some other questions, but I think that we also have one more post for questions by the end of the talk. So why wouldn't we continue?
Yep, sure. Okay, and I'll just say I have noticed that there's a question about Gradle module metadata transitive dependencies. I don't know anything about that, I'm afraid, so I can't talk about it. Hopefully it does try to get rid of some of the problems. Whether that does it via shadow jars and things, I'm not entirely sure. Okay, so we definitely had some questions around network APIs and microservices and things. And there are multiple approaches here. If you've used Azure APIs and AWS APIs, you will have seen different schemes. I have worked fairly extensively on different approaches within Google, so I can tell you a little bit about what our current thinking is. And I've had to change these slides several times because our current thinking changes, and this is sort of current best practice. But when I'm talking about network APIs, I just want to be really clear that I'm talking about making RPCs, and exactly how it applies to REST, whether you include versions in headers or a URL or a query string, it's important, and there are definitely pros and cons, but that feels slightly less important to me than what versions you make available in the first place and what versions you talk about and document. Now, when you're thinking about network APIs, if you're designing a versioning scheme, as I'm sure you all are, you need to think about all the stakeholders. So you have end users, developers, who are going to call your APIs, and they would like, in an ideal world, they never want to be broken. They never want to have to change their code ever. On the other hand, they also want new features, and they want those to be perfect for their situation, and maybe that's different from what they wanted before. So you might want to make some breaking changes. You also have the API producers themselves. So, for example, the Spanner team I talked about earlier on, Spanner. Then you have infrastructure teams. So it's not like the end user makes a call directly to the Spanner server, and that's no code is written by anyone other than those teams. There are, at least in Google, API infrastructure teams who try to keep everyone doing the same thing in versioning, and they run, it's not quite proxies, but wrappers around that can make common code, common calls and things for logging and authentication and stuff. So there's definitely infrastructure teams. Then the equivalent of the infrastructure, but on the end user side, is the client libraries and tools teams, and that's where I sit. I build client libraries for things like the Spanner API. So I need to know how things are going to work. I want the APIs to be stable. And also, an often missed bit of this is API reviewers. When you're making a change to an API, how do you review that change? You need to know when you're reviewing, is this meant to be a breaking change? Does it matter if, let me give you a concrete example, if I'm reviewing change number 3 and it removes a field, that sounds like a really breaking change, and it would be, but maybe that change was, that field was only introduced in change number 2, and that was never published to users. So you're adding and removing a field between change 1 and change 3, and never publishing that intermediate bit. That's fine. That's not a breaking change. So you need to have this whole, all the context available about what's been made available in what way. Now, in Google APIs, we describe all our APIs in protocol buffers. They're effectively a serialization format, and a protocol buffer message is within a package, and it has a message name. And in our APIs, we put the version as the last part of the package. So here are some examples of APIs, and we have services within it. And what I haven't shown here, this is the KMS service, and that would be in a package called google.kms.v1, or maybe v1 beta. And this is where things get interesting, and maybe v2. So what you need to think about is, how is the client calling the API? In our case, we have JSON or protobuf after gRPC. What does the client care about in terms of if we make a breaking change in an API? Suppose we remove a field that was previously there, but we're pretty sure no one's ever actually used that field. Then it's a breaking change in the library, but we prefer not to make it a Semver major change because our diamond dependencies earlier on suggest that's any major change is painful, even if it doesn't break anyone, because you're saying that it might break someone. So any library, depending on your client library, when it updates its dependency by a major version, needs to do a major version itself. It all trickles up and causes problems. So, how do we manage that? What are the rules for a compatible change? In protobuf, internally, a wire format change, something like changing it from, I'm trying to think of an example of a wire compatible change. You could change something from a string to a byte string. So it's going from text to binary, but they're both represented the same way. And so long as all your clients are happy with that, if the client thinks it's sending a string, the server can receive it as a byte string with no problems. But then as soon as you publish that, that is a breaking change in the API surface. So it gets really tricky. What we have landed on at the moment is this. So services don't have minor versions or patch versions. They only have major versions. And also they can have pre-release versions. So typically we would say that alpha releases are meant to be, private. They're on allow list basis. So we would have customers talking to us and say, I would really like to try the new features in your Cloud Vision API. And you say, okay, that's fine. I will put you on an allow list for V1 Alpha, and maybe I'll give you some documentation. I may give you a client library that talks to our V1 Alpha service, and then you can use it. Or maybe we say, okay, we will expose those within the V1 API through something that stops anyone who isn't on the allow list from being from using that field or that method or whatever, and we can give you another client library that says it's for V1, but it's not. It gives you more than just the V1 API surface, the public API surface. So those are two ways of handling alpha. When it comes to beta, we would normally be public. So we would say, here's the V1 beta API, and here's the V1 API. And we would want the beta to be a superset of the V1. So you should always be able to say, I will take my code that talks to V1, make it talk to V1 beta, recompile, rerun, everything should still work. But then I can also use the new features of V1 beta. And this also starts then talking about two different kinds of stability. We've been talking about compatibility and stability in terms of the API surface. If I rebuild my library, if I rebuild my application, it will still build. I won't have just deleted some RPCs, for example. What about the service stability? What about the service level agreements that say, all calls to this service must complete within 1 second or whatever it is? Chances are for the V1 beta, that sort of channel of the service, we may not make the same guarantees, or we may make the same guarantees for the RPCs that are in V1. If you're not using anything from V1 beta, then maybe we should give you the same guarantees. Maybe we shouldn't. Now, this talk isn't about how Google does its APIs. It's really meant to be encouraging you to think about how you would design your own APIs, your own API versioning strategy. It's telling you about the kinds of thing that I've been thinking about, the kinds of answers that we have come in, have thought about. and then take that information, adapt it. Don't just take my answers and say, well, if it's good enough for Jon, then it's good enough for me. I want you to understand why we've come to those ideas and then see, does that actually matter for me? Maybe your APIs are only used internally. Even if they're microservices, you may know everything that's using it and be able to deprecate something on a Friday, and then your whole system rolls out the following Monday, and maybe you wait a week so that you know there won't be any rollbacks, and after that you can remove an old method that is no longer used. So even within microservices, it can be trickier, but still you can make breaking changes in a relatively short time span. Whereas the idea of taking a V1 method, deprecating it on a Friday and removing it 9 days later in Google, that's just not going to fly. Finally, let's just talk a little bit about cloud events. So this is something I have been getting into just recently. I'm part of the team building the Google Cloud Functions for .NET support. Our alpha has literally just gone live or is going live this week. And I will pop in the chat the functions framework that I've been working on. So just grabbing the URL. So this is to allow you to deploy to Google Cloud Functions really quickly. And the tricky bit is when you deploy a function that is going to be triggered by an event. So a pub/sub message being published, or maybe something in Firestore or Firebase, the cloud audit logs, maybe a storage change. So I've got an example of Google Cloud Functions, which just listens for a change in a storage bucket, so like a blob store bucket. And if someone puts an image file into the bucket, then I pick that up, ask the Vision API to do facial recognition and logo recognition and label recognition, and then I write a text file that sort of describes that image alongside the image itself. So I need to respond to an event. What should that event look like? The cloud events have something called a type, which is a string like google.cloud.storage.object.finalized. That doesn't have a version in. What if we want to change what's in that event for a V2? So I've been arguing, and we're hopefully moving to a system where the event type string that ends up in the cloud event has a version in as well. How does that tie into API versions? Well, that gets even more complicated. But this is just one extra thing I've been thinking about. So to conclude, this is a complicated topic that we're really bad at the moment. I hope you've been sort of slightly scared by all of this, but also that you'll go away and think about how you use versions, how you publish versions, and all the different nuances. Maybe you'll come out with a way that .NET can start to implement Semver rather better, because even though it's the de facto standard for .NET, we really don't do it properly. I hope we will be able to do more, and I hope you can be a part of that. And finally, as I said, I would end, please be kind, in this case, to people using your code, and part of that is working with versions properly. Okay, with that, I'm going to go back to questions for the next sort of 5 minutes or so, and then we'll have more questions in the Zoom webinar.
Yeah, so I believe that you have already answered the question about Gradle module metadata during the previous question break. So the next question is, which approach is better for versioning of microservices and gateways, including cases when we have more than one gateway for different applications?
So I'm not going to answer that sort of very directly. I've talked about some of the things that I think about when doing, I guess, macro API versioning. When it comes to microservices, if they're internal, rather than give you the answer, I would say, look at what I said about who you need to think about. Design your versioning strategy around that. Maybe you don't need to have, maybe you can make breaking changes via deprecation. So you might need to have two different versions if you were doing a major project that would be completely breaking and there's no way that you can easily sort of migrate piecemeal, maybe you need to have a V1 and a V2, and it's useful to have those version numbers right from the start, even if you think you may only ever need a V1. But within V1, maybe you can take breaking changes after a deprecation period when you can validate that no one's going to be broken by it because you own all the code that calls it. So yeah, I hope that isn't seen as ducking the question too much, but it's really a case of going back to the context and how do you need to support ongoing development, and how do you need to support the callers of the microservices, and how are you testing this? Do you have good staging environments that you can say, okay, maybe I will roll out my new version that deprecates something or that removes something to 1% of traffic and monitor it and roll back quickly, redirect that traffic if it turns out that it's breaking things and we hadn't expected it to because we deprecated it a week ago. Things like that.
Okay. So the next question is, if you were to design your own iVersion interface, what would be its members beside of the obvious one, is breaking my code property?
So I guess this comes back to having some common idea of what counts as a breaking change. I think, and I have been thinking about this, we have a tool that we use within the Google Cloud.NET repo for client library detection, written by a friend of mine, Chris Bacon, that decides what the next major version, or so the next version should be based on, right, these are the changes and these ones are breaking, these ones are not breaking. So I think it only ever says minor or major. But I would like the next iteration, the next version of that tool to, instead of saying this is major, this is minor, separate it out into two stages. Say, these are the changes that have happened and have a full description of all of those changes, and then be able to have a configuration file that says, this is the set of changes that I deem to be major changes. This is the set of changes that I deem to be minor changes. This is the set that I don't care about. So maybe you have internal members, and for the most part, internal changes should be seen as not major or minor. They're just a patch release, the refactoring question earlier on. On the other hand, if you've got other libraries with internals visible to, and I would strongly urge you not to do this between production libraries because of exactly this change. You might think you can delete something internal, but actually I've got this other library, that's at version 1.2, and someone might upgrade just the other library due to other dependencies, and so my internals visible to make that internal member effectively public, and so you would have to configure removal of internal member to be, this is a breaking change. Okay, so I would like to be able to have that common, common across the .NET ecosystem. This is what what the set of changes, how they're described. You have an identifier for each, and maybe you have groupings. I don't know exactly. But then have a configuration file that could be part of, that's published in your repository, and then say take the configuration file and the detected set of changes between old and new, and say, well, that means I should do a major version bump. And then when someone who depends on you looks at the new major version bump, they know what that means, or they know what it can mean. And you could also publish as part of the new release. You could say, okay, this is the set of changes in a machine readable format, and then that would allow someone to say, okay, it's a major thing because this was removed, but that doesn't affect me, so I'm okay.
Okay, so the next question is related to your current position at Google, I believe. So do you use any particular Git branching model, Git flow or GitHub flow within your release cycle, and how it relates to versioning?
So I'm entirely ignorant of what all the different names. I have tried to look at what GitHub flow and Git flow mean. and the descriptions tend to be in terms of what you do rather than what the effect is, and I find that hard to follow. But I can tell you what we do, which is we have a repository, Google Cloud.net, and that fork that is sort of the primary fork. And then each developer on the team has their own fork. So I have the jskeet / Google Cloud.net fork. I create a new branch whenever I'm doing any work. So I don't do any work on the master branch, which I'm hoping will eventually be called a default branch or a primary branch, something with less problematic connotations. And then I create a pull request that is my branch in my fork to the primary fork's primary branch, master branch in Google APIs / Google Cloud.net. And that just goes on to master. We almost never use separate branches that are long-lived on the main repository, the main fork. What we do when we do a release, we will tag wherever we're building it from, which is usually the primary branch. So we can get back if we need to. And then if we need to create a patch, at that stage, we will create a new branch so that we can do the patchwork and keep them separate. That's within Google. Within Noda Time, we have a very similar but slightly different approach, where same thing in terms of forks, but whenever I do a minor version, I then create a branch. So I have a 1.1.x branch, 1.2.x branch, 1.3.x branch, 1.4.x, 2.0.x, 2.1.x, etc. And everything is released off a branch. The reason that doesn't work as well for the Google Cloud.net repository is we have 80 libraries or something crazy that's released from the same repository. I don't want to have that many branches, or rather that many branches times the number of minor versions, because they're each individually versioned. So, the Google Cloud Spanner library I'm releasing today, or set of libraries, they're all at 3.10 beta 1. But yesterday I released Google Cloud.os config version 1.1.0. 1.0.0. So having one version number across all the libraries really wouldn't work, and that makes it harder to branch. So this is just another example of how the context really, really matters. Question we have time for in this context. Is that right, Max?
Yeah, it's interesting. Now I can claim that we follow almost the same approach as Google do.
Hooray!
Because what you have just explained is almost exactly the first approach that we normally do in our project. And I kind of like the fact that you follow different approaches based on project situation, because it doesn't make sense to follow the same process all the time, because, well, the situation is different.
I can't think of any situations where one rule applies to everything. It's just, it doesn't work.
Yeah, but still people tend to look for the silver bullets.
We all like simplicity and silver bullets, yeah.
Yeah. So a completely hypothetical question, though, about tooling. So what do you think if we had automation, like some kind of tool which can check NuGet and determine whether the changes in the published version are following some versioning or not? So, and if it's not following, then the field would fail.
I have exactly that kind of tooling within Google Cloud.net for what we consider to be breaking. But as I say, I want that to be more configurable over time. Speaking of time, I think we're about to run out of time here, and the next session will be starting very shortly, I believe.
Yeah, thank you, guys. It was a great talk as usual, and I invite you to this discussion zone